This is a series of 4 graphing review, one of tangent, one of cotangent, one of sine, and one of secant. It will be broken up to 4 parts because of the size of the video. So starting with this first one is the tangent graph. Let's review over the 5 critical points of a tangent graph. We're going to start the tangent graph on a 0. Wherever the graph starts, it will also end in the same location. Therefore, the end of the period is also a 0. And halfway through the cycle, you would have an asymptote. All right, between the 0 and the asymptote at halfway point, which is a quarter of your period, you would have a value on 1, provided that A is positive, and -1 when A is positive as well. All right, if A is negative, those points will be flipped over, so you have -1 with a positive negative A and a positive 1 with a negative A. So the general behavior of the graph would be that if A is positive, the overall tangent graph will be right-handed, which means it is increasing, going up. If A is negative, the tangent graph will be going down, decreasing. All right. A normal tangent graph has a period of pi, so therefore the horizontal stretching will deal with the b value, so it would be pi over b, whatever b might be. In this case, your b in this problem is a 2, so the period on this graph would be pi over 2. Now that I have the period in place, I want to go ahead and mark my scale on my graph. Generally, we use 4 tick mark for 1 pi. So here's the pi, and counting out another 4 unit, here's 2 pi, and so forth. All right, there are no amplitude on the tangent graph, just a stretch and shrinking vertical factor. In this case, it's going to be a 1, so there's no shrinking or stretching. So I'm going to write down no asymptote. Phase shift, there is not a phase shift in this problem, so therefore is none. And a vertical shift has to do with the d value, so it would be -1 coming down 1. All right, so we'll begin by go ahead and drawing your asymptote in. So you would please take a dashed line, draw the asymptote in 1 unit down below the x-axis, say right here, all the way across the graph. All right, so we begin with my graph on a 0. So a 0 would be at the origin, but because we shifted down here, this is my new pretend origin, so I'm going to start my graph down here. I'm going to then measure out a period of pi over 2. So since pi over 2 is 2 count, or 2 unit here on the scale, we're going to count 1, 2, and we're going to end that period on another 0. So we just graphed 1, start, and end. Now between those two zeros, you're going to put 3 other critical parts of the tangent graph. The one right in the center, halfway between those 2 points, would be a vertical asymptote. So I'm going to put a vertical asymptote down here. And when I do that, I want to make that a little bit different than when shift lines. So I want to make this a little bit longer. Little tick mark down this way. All right, between every vertical asymptote and 0, there will be a value at 1 and -1. So at 1/4 mark, since my tangent it's going to be a negative value here. So it's going to take on the behavior of a decreasing graph as such. So I know that I'm going to be using a rotation up and down through this your shift. So I'm going to go down 1 here, so my graph actually will connect down this way. So it will be a decreasing graph, and therefore it will have a point up here as well. Now remember, there is no amplitude, but we do have a stretch factor, and here the stretch factor would be simply a 1, so that it's like behave like a normal graph. So your graph will look like this, coming down, connecting those points, and it's going to come writing down the asymptote as such, like this. This completes really one cycle, but if I was to continue, remember we need a minimum 1 period plus 1 critical part to the left side of the y-axis of the origin. So I am going to go ahead and put another asymptote down. Okay, remember between every asymptote on a tangent graph is a distance of pi over 2, and between every pair of 0 is a distance of pi over 2 as well. So there's my asymptote here. If I wish, I could put another one down. And halfway between those two would be my 0, and my 0 is going to be right on my new baseline, on my shift line that's down here, not on the true x-axis. All right, my other points, which are my quarter point, would be at 1 here, then -1 here, and then +1 there. So I'll go ahead and connect those, keeping my graph in line with my, oops, missing me. Okay, in line with my asymptote. So it'll be going down like this. Okay, so right now the graph is basically completed with 2.5 cycle. You can continue on if you like to finish up this one with another vertical asymptote here, or you can go ahead and stop the graph just to make sure that you have given me 1.5 cycle with 5 critical parts. All right, now to finish up the domain is all where except where the asymptote exists. So it's going to be every real number except where x cannot be where the asymptote exists. So I'm going to go ahead and just pick one of these asymptotes out, which is this one. I'll just pick the one closest to the y-axis. And since this is 1 tick mark away, that would be 1/4. So we're going to say is that pi over 4. Plus the distance between every asymptote is that period. So we're going to put plus a period of n pi over 2. The range for all tangent graph will be all real. And your vertical asymptote equation is similar to your domain, is where your domain does not exist. So it's going to be where x equal to pi over 4 plus n pi over 2. All right, this concludes the first part of the video on the review of your trig graph. And I'm going to go ahead and post this now.